Dear children, so welcome to the session. Let's continue with that activity 4.5. So we have to take that sodium metal. We have to cut it into small pieces and we have to handle them with a pair of tongs, and we have to dry it by using filter paper and wrap it in a small piece of cotton. And put a piece, that is sodium piece, wrapped in cotton into the beaker. So we have to put the sodium piece into a beaker and observe carefully. So during observation, keep away from the beaker. So in the beaker, what is there? Yes, water is there. So in that, we have to put the sodium metal piece and we have to observe that. So what happens? The sodium metal is very reactive. So it's very reactive. So it reacts vigorously with oxygen and water. So the sodium metal is highly reactive. It reacts vigorously with oxygen and water. So it catches the fire. So you can see here, no? So it's a beaker. So in that beaker, the water is there. So in that, when we put the sodium metal, so what happens? Yes, it catches fire. Because the sodium metal is very reactive. It reacts vigorously with oxygen and water. So this activity we have to do very carefully. So when reaction stops, touch the beaker. So after the reaction is completed, so we have to touch the beaker. So what happens? So what happens, children? When we touch the beaker means you can feel the beaker is hot or not. Yes, you can feel the beaker, it will be hot. So what do you feel? Has the beaker become has the beaker become hot? So when we touch the beaker, you can feel the beaker is hot. So why? What is the reason? Because the beaker becomes hot because lot of heat is generated in the reaction. Because the sodium metal reacts with the water, so it will produce the heat. The heat energy is exposed, no. The lot of heat is generated in the reaction. So that's why we have to store the sodium in kerosene. So that is the reason the sodium metal is stored in kerosene, because the sodium metal is very reactive. It reacts vigorously with water and oxygen. So when it reacts vigorously with oxygen and water means, so what happens? A lot of heat is generated in that reaction. So that's why we have to store the sodium in kerosene. So test the solution with red and blue litmus paper. So we have to test the solution. Is the solution is acidic or basic? So we have to identify. We have to test with the blue litmus paper and red litmus paper. So what happens? The solution is basic because it turns the red litmus paper to blue. So the solution is basic in nature. So actually what is the reaction goes on? Let me write the equation first. So what is the reaction? So what we have to take? That sodium metal. So what is the formula for sodium? Na. So the sodium is reacted with water, H2O. So what does it forms? It forms sodium hydroxide, NaOH plus hydrogen gas is liberated. So this is the reaction goes. So what does it form? It forms sodium hydroxide. Sodium hydroxide. So it's acidic or basic? Sodium hydroxide is acid or base, children? Yes, it's base. So that's why when we dip the red litmus paper, it turns to blue because it's basic in nature. What is the product is formed? Sodium hydroxide is formed. Sodium hydroxide is basic in nature. And so sodium reacts vigorously with water. Some other metals do not do so. So only sodium metal reacts with water. Other metals do not react with water because other metals are less reactive. For example, iron reacts with water slowly. So iron reacts with water very slowly because it's less reactive. So we can tell it as only few metals reacts with water. Other metals do not react with the water. So what is the reason? It's less reactive. And chemical properties of non-metals. So what happens when non-metal is treated with water? So what is the product is obtained? So generally non-metals do not react with water, though they may be very reactive in air. So generally the non-metals are not react with water. They react only with presence of air. And such non-metals are stored in water. So that is, some metals, non-metals are reacts with air, no. Though they may be very reactive in air. So some metals do not react with water. Will not react with water. But the non-metals are very reactive in air. So that non-metals are stored in water. So for example, phosphorus. So phosphorus is very reactive non-metal. So that non-metal is stored in water. So it catches fire if exposed to air. So when phosphorus is reacted with oxygen, phosphorus is reacted with air, it catches fire. So that's why to prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. So that is the main reason that phosphorus is stored in water. So we can conclude with Generally, non-metals do not react with water, though they may be very reactive in air. So that non-metals are very reactive in air. So that such non-metals are stored in water. So for example, when you take phosphorus. So phosphorus is very reactive non-metal. So when phosphorus is reacted with oxygen, it catches fire. So to prevent the contact of phosphorus with atmospheric oxygen, so phosphorus is stored in water. And we can go for sodium. When sodium reacts with water, so what happens? It catches fire. So that's why to prevent the sodium which is contact with atmospheric oxygen and water, so that sodium is stored in kerosene. So that's why the sodium is stored in kerosene. And we can come for the non-metals, that is phosphorus. So that phosphorus is reacted with atmospheric oxygen, it catches fire. So that's why that phosphorus is stored in water. So why we can store in water? Because non-metals does not react with water. Will not react with water. So that's why we can keep the non-metals in water. No reaction will take place. That is the main reason that non-metals are stored in water. And usually, so non-metals do not react with water. So we already discussed now. So, except for chlorine. So chlorine dissolves in water to form an acidic solution. So when the chlorine is dissolved in water, it forms acidic solution. So it forms hydrochloric acid, HCl. So when chlorine is dissolved with water, it forms HCl. So this is the chlorine formula is Cl2. It's treated with water. So what does form? It forms HCl, hydrochloric acid. Form hydrochloric acid solution. So this is the exceptional cases. Except chlorine, so all non-metals can be stored in water. If we store chlorine in water, it converted to HCl. Hydrochloric acid is acidic nature. Okay children, so see you on next session. Thank you.